Hello everyone. So we have talked about siliciclastic sedimentary rocks and carbonate sedimentary rocks, and we're not going to talk about the biochemical and biogenic sedimentary rocks in detail. So we're skipping chapter 7, and now we are starting chapter 8. And in chapter 8, we're gonna start to talk about depositional environments. So we all know that the characteristics of sedimentary rocks, such as the texture and the structures, they are closely linked to the depositional process, such as it's a unidirectional flow or bidirectional flow. It's the flow velocity. So all these process, so a sedimentary rock's property linked to sedimentary process, and the sedimentary process, on the other hand, is linked to the depositional environment. So, such as the environment decide what's the depositional process. For example, in river in depositional environment, then the flow will be unidirectional flow, and the river is a large river or a small stream, so it's gonna decide the flow velocity. So the depositional environment decide the depositional process, and the process gonna decide the depositional property. They are all linked. Therefore, we can use the deposition characteristics of depositional rocks to interpret the depositional environment. So we in this sequence of chapters, we're gonna move from terrestrial depositional environment to marginal marine and marine environments. Okay, first, the fluvial environment. Fluvial environment, there are different types of rivers, and based on the channel morphology, we divided rivers into meandering stream and braided streams, and in the middle there is anastomosing streams. So meandering river is characterized by single channel river channel, while braided rivers has multiple channels. And this meandering river, it meanders, so the channel is sinuous, while braided river, the channels are relatively straight, while anastomosing river channels, it has multiple river channels, but the river channels are sinuous. Based on the morphology, we characterize the river into three categories. That's a meandering river system, braided river system, and anastomosing stream. Another thing to mention is that the river channel morphology is also depending on the landscape. So meandering river, in this case, meandering rivers are usually developed at a flat area. So the channel stability is relatively high, and the flow velocity compared to braided rivers, flow velocity is relatively low. The channel deposit is usually fine sediments and relatively constant flow with dense vegetations because of the stable land stability, so that develop soil as well. On the other hand, braided river streams usually develop at steep slope landscape. So it's near mountains area. The flow velocity is relatively high, and the channel stability is very low. So rivers switch channels very often. Then the sediments are coarse, and then the flow velocity can be variable, such as near the mountain. If there's a rain, then the flow velocity gonna increase dramatically. So and then the vegetation will be less. The low land stability and which is also not favorable for soil development. So that's the three types of rivers. And now we are gonna go look at the meandering river first. So meandering rivers channels are meandering, and we have a channel deposit and floodplain. We have a channel and floodplain, and sediments deposited into these two sub-environments as channel deposit as a point bar, and floodplain, which is called floodplain deposit. So as you can see, in this area is relatively flat, and the river channels are stable. So which means so channel stability is high, which means the channel will follow this. The river will follow this channel and flow within this channel, and the new channels are not often developed. So here, let's see, this is the point bar. This is and then this is a river. So the river channel is from here to here, and the river channel deposit will be this point bar. We call the river channel deposit as a point bar. Okay. So if we want to understand how the point bar were formed, we have to understand the depositional process within the meandering river. And on this side we call it cut bank, and on this side we call it point bar with deposit. So there are different sub-depositional environment within meandering river depositional system. It includes floodplain and a point bar. And on floodplain, we also have different sub-depositional environments such as levee, crevasse, splay, swamps, and oxbow lake. And the point bar is also called lateral bars or set bars. It's in this inside of this river channel ribbon. How this sub-depositional environment developed is all because of this river meanders, and it erodes the cut bank side and deposit on this inside of this river. So how does this happen? So helical flow is a characteristic type of flow that within the meandering rivers. So as the river flows, the streams go this helical shape. So it not only carries the fluid flowing this way along the channel downstream, but it also generates a circular flow like at the cross section. So there's the flow vector is also going this way, and the flow velocity is higher on this side than this side. What will happen is that it erodes this side of the bank. Well, because of the internal, there's also an internal flow like this. In this motion, the eroded bank material will also be transported to this side of the bank. And remember, the flow were faster on this side and slower on this side. And when the sediments were transported from this side to this side, flow velocity decrease. What happens when flow velocity decreases is that the deposition gonna happen on this side, right? So the helical flow is the reason why we have a cut bank being eroded, and on the other side of the bank will be deposition happens. So the point bar deposit is accumulating from this side and go laterally on this way, and this because of this side is keep eroding, this side keeps the deposition happening, then this river channel is slowly moving this way. So that's why the meandering river can meander, because the cut bank side is eroded and the point bars is depositing and the river is meanders this way. Okay. So this is why we have a point bar deposit within the river channel. And I also want to point out that, remember, we are saying why the deposition is happening on this side is because of internal flow direction from eroding this bank and transporting sediments on this side, and it makes the point bar accumulating from this way to this way. However, please remember that the river is actually the major flow direction of the river is this way. So when we have a sediment structure develop over here, it's still, even though it's accumulating this way, but still the dominant sedimentary structure, if we look at it as a ripple, then it shows the flow direction will be from this side to this side. So it is in and out the stream. This also is another picture showing how helical flow makes the sediments deposit eroding on this side and deposit on this side of the channel. So you can see, if you look at the depositional structures within the within point bar deposit, then it is trough cross bedding here, and then if you look at here, this represents the grain size. So the grain size is coarse at the bottom and fine at the top, so it's a fining upward, because as we go upward, the flow velocity decrease. But it is all dominated by dunes and ripples because of the unidirectional flow in the river channel. As I said, when we have a meandering river on the cut bank side, we're gonna keep eroding, and on this side we will have a point bar deposit. So the river meanders in this way. We have a cut bank on this side and a meandering on this side, and once the river turns and the river cut bank is on this side and the point bar deposit on this side. So this is the deposition of the river channel, and outside the river channel we will have floodplains. So the floodplains area, we also have a subdepositional environment. These are sediments deposited during the flood. So as it's called floodplain, that means at the normal time, when there's no flood, there's no deposition, and therefore there will be soil developed. However, flood happens once or twice. Small flooding may happen once or twice every year, while the large flood maybe happens hundreds of years once. So immediately outside the river channel, there will be a levee developed. Why is that? Because this flow were constrained by this channel, and once the overflow happens, the flow velocity within the channel gonna decrease dramatically. And then when velocity decrease, we're gonna deposit a bunch of sediments right near this channel. So right at the edge of this point bar, and we're gonna dump quite amount of sediments, so we'll make a small levee over here. and then the flood just spill to the floodplain and deposit finer grades mud on this flood and maybe makes it a swamp. Okay, so once this levee developed, then when the flood happens again, this is there's at one of the weak points will break and then will becomes an outlet. And this outlet, what gonna happen is that the next time when flood happens, this levee gonna block some of the sediment. This outlet, there will be quite amount of sediments deposit at the mouth of this weak point. So it will be like a fan shape because it's from one single outlet, and just this flow velocity gonna decrease from here to here. So then the velocity decrease and we have sediments deposit on here. And these sediments, the texture of these sediments gonna be similar to the levees because because here and here are blocked, and the similar sediments are gonna go out from here and deposit in a fan shape on the floodplain like here. So this is a floodplain deposit and the subdepositional environment, we call it.
Turn a straight stretch of river into a bendy one is a little disturbance and a lot of time. And in nature, there's plenty of both. Say, for example, that a muskrat burrows herself a den in one bank of a stream. Her tunnels make for a cozy home, but they also weaken the bank, which eventually begins to crumble and slump into the stream. Water rushes into the newly formed hollow, sweeping away loose dirt and making the hollow even hollower, which lets the water rush a little faster and sweep away a little more dirt, and so on and so on. As more of the stream's flow is diverted into the deepening hole on one bank and away from the other side of the channel, the flow there weakens and slows. And since slow-moving water can't carry the sand-sized particles that fast-moving water can, the dirt drops to the bottom and builds up to make the water there even shallower and slower, and then keeps accumulating until it becomes new land on the inside bank. Meanwhile, the fast-moving water near the outside bank sweeps out of the curve with enough momentum to carry it across the channel and slam it into the other side, where it starts to carve another curve, and then another, and then another, and then another. The wider the stream, the longer it takes the slingshotting current to reach the other side, and the greater the downstream distance to the next curve. In fact, measurements of meandering streams all over the world reveal a strikingly regular pattern. The length of one S-shaped meander tends to be about 6 times the width of the channel. So little tiny meandering streams tend to look just like miniature versions of their bigger relatives. As long as nothing gets in the way of a river's meandering, its curves will continue to grow curvier and curvier until they loop around and bumble into themselves. When that happens, the river's channel follows the straighter path downhill, leaving behind a crescent-shaped remnant called an oxbow lake.
I'm going to talk about the meandering river depositional system. Here I draw a meandering river with an oxbow lake developed over here. And we discussed that meandering river, the channel deposit will be point bars. So with Oxbow Lake, the old channel has deposit point bars over here. And then the current active channel develop point bars at these places. And then we're going to talk about the floodplain depositional environments, the sub-depositional environments of the floodplain, which includes swamp. Swamp will be the most area here, the blank area here, which is the floodplain, and mostly deposit mud during the flooding periods. And then Oxbow Lake we already have. Then later I'm gonna explain levees and the crevasse splay depositional environment. And then we will draw a cross section of this meandering river system and draw a stratigraphic column. So the cross section and the stratigraphic column is very important. It will for sure be in the exam. Okay. So levee, how does levee develop? So during normal time, most of the time the river flows, and the flow will be confined by this river channel. So the flow velocity is relatively fast. And during flooding periods, even though there is such increase in the flux of the river, then this river will overflow. So when the river overflow happens, the constraint of the river from the channel will disappear, and the river just go everywhere. So when that happens, then the velocity of the flow will decrease dramatically. And when velocity decreases dramatically, what happens is the carrying capacity of the river will decrease very fast. So along the river channel, there will be deposition happens at short periods of time when the river overflows. So on both sides there will be levee developed, and this levee will just the sediments deposited in the levee will be mostly sand deposit. And once this sand deposit, once the sand is all dumped near the confined channel, then mud will be deposited on the floodplain. And once this levee developed, there will be weak points, and the weak points will be places. Then the next episode of overflow, then weak point will be broken, and then rivers, the water gonna go out from here, and then deposit the sand. Those sand will be otherwise deposited as levee. So this weak point will have a sand deposit and then finer grains outward. It's a fan shape deposit. This is called crevasse. So a crevasse splay is a weak point broken from the levee, and then the river water overflow and then deposit a fan shape sediments called a crevasse splay. And a crevasse splay will be, the sediments over here will be slightly coarser than the surrounding floodplain depositional in floodplain environments. Okay, so this is a swamp, oxbow lake, levee, and a crevasse splay. If we draw a cross section from floodplain over cross oxbow lake, point bar, active channel to then all the way to here from A to B. I want to show you draw a cross section from A to B. So a cross section over here, we're starting with floodplains. A floodplain is mostly laminated mud, right? And then we'll have it. Okay, so will be muddy oxbow lake. And then within the oxbow lake, we have some mostly will be laminated mud deposit. And this is just swamp mud over here. And then on this side, we'll have point bars deposit. Sandy point bar deposit. Okay, and then later we will have, out of those point bars, we'll have laminated mud deposit over here. Okay, then over here we'll have another active channel. So on the active channel, we'll have sand deposit, sandbars deposit as again. And then we'll have more mud swamp deposit. And then we reach to this crevasse splay. We'll have what we have is laminated sand and then mud and laminated sand and mud deposit. So a mud deposit and the sand. So here at the crevasse splay area, we will have a sandy deposit and a mud deposit over alternating beds. So that's from A to B, and then don't forget that we will have levees on both sides. Those are levees. Okay, so this is from A to B as a cross section. And also, if we look into the history, geologic history, then the basin, deeper of the basin will probably have more river deposit, and what we will find are those sandbars deposit here and there, like this. Sandbar deposit like this, and then surrounding will be all mud, laminated mud that are floodplain deposit. And of course, except that, we'll have some of them has a crevasse splay deposit. And what else we will have? Remember, this is a swampy area, and without flooding, here we'll have soil development. So here we will have soil development, and within this area we will have soil development as well. Okay, so that's the general meandering river depositional system, a cross-section from A to B, including channel deposit, channel sandbar deposit, as well as the floodplain sub-environments. Then I want to show you, show you if we draw a stratigraphic column. Okay. So I lied. I didn't draw a stratigraphic column over just based on here. I just draw a typical stratigraphic column with of a meandering river, including channel deposit and floodplains. To draw stratigraphic column, first you need to do is to set the scales for grain size. And gravel, mud, sand, and gravel, and will be thickness on this side. So if we draw a typical stratigraphic column for meandering rivers, at the bottom we'll have gravelly sandbars deposit, like erosional surface, and then later this deposit will be fining upward. So then sandbars will be characterized by ripples and dunes, sandy, gravelly deposit. And on top of that, we'll have more crossbeds. As the channel goes shallower, the grain sizes will be smaller, and then we'll have more thinner beds deposit, right? And then we'll have some ripples as well. So these probably will be dunes, and ripples they will start to develop at the shallower channel, like this. And cross lamination, cross beddings, or maybe trough cross beds. So it's a fining upward succession, and then we reach to, then we'll have a floodplain deposit. So flood. Remember, sometimes when we have a crevasse splay, we'll have some sandy deposit. So this all will be mud, and sometimes we will have a sandy deposit. Okay, so from here will be floodplain, and from here to here will be channel. Then floodplain, on floodplain we'll have a texture characterized by sandy mud. That's the grain size, and the structure will be planar lamination. And the point bars. Texture will be at the bottom. At the bottom we will have gravel, and mostly sand. Sand could be coarse sand to very fine sand. And the structures will be dominated by unidirectional flow structures. Will be cross beds, which includes cross lamination, cross stratification. Also includes ripples. So cross beds, ripples. That will be the characteristic structures. So overall, a meandering river stratigraphic column will be fining upward and characterized by the channel deposit, characterized by unidirectional flow structures with coarse sediments, gravel, and sands and floodplain deposit will be characterized by sandy, will overall generally be mud deposit, but in some layers where crevasse splay and levee deposit, we will have a sandy material within floodplains and some soils as well. So that will be all for explaining the depositional system of a meandering river.